Right, so I'll make a start then. So we've done on chapter 2. The last 2 sessions have all been about the different operators. You can see all the test classes there. We've been through all those, and there's just one to do. It's a ternary operator. So it's a bit of a different one because it's actually got 3 operators involved in it. It looks a bit strange first time you see it, but you kind of get used to it. So there's an example of one there. It's where you have you have 3 parts. So this statement, which is a string there, is going to take the value of, and then you have a ternary expression. So you've got, if you can see, you've got 3 operands, and it's easier actually. It's always easier if you use brackets just to show what they are. So even though that would work as it is, you can see that is the first operator in a ternary expression, and you can tell it's a ternary expression because the question mark gives it away. It's also a bit of a clue because the question mark's quite appropriate because it is kind of like asking a question. So what you're saying is, I've got a string called statement here, and I'm going to be assigning the value of that something. So based on the first part of the ternary expression, we're asking, is value, which is an int, which we've initialized to 3, is it equal than or greater than 3, which it is. That's going to be true. So the first part of a ternary expression has to return a boolean because you're asking a question. You're saying, right, based on this, if that returns true, then we take the first thing after the question mark. But if it returns false, then we take the second thing after the question mark. So that's like if we just put them all into brackets. I know you don't really need to because we're dealing with strings here. So ternary has 3 operators, and each of the 3 are separated into bracketed statements now, and then you have a question mark to ask the first question, which has to be a boolean, and then the next 2 are separated by a colon, like that. So what we're saying is set the value of statement based on what value is the value of value is. If it's greater than or equal to 3, that's going to be what we assign it. If not, it's going to be that. So if we just if we do it like that, just see what it says. I've run the wrong thing there. Ternary operator. That's it. So it's gone there, equal to or greater than 3, as we expected. Obviously, if that's 1, it'll go to the other one. I'll print out the other thing. Equal to or greater than 3. Sorry, I changed it in the wrong place. It's that we're testing, so change that to 1, and it's less than 3. But I've kind of gone a bit ahead of myself there because I've gone straight to the ternary operator there. But what ternary operators are basically for, they're kind of like an alternative to an if statement. So if you look at this if statement here, and we're going to go into if statements in more detail in a minute, but this if statement is doing exactly the same as that ternary expression. It's saying if value, which is this thing here, is greater than or equal to 3, set the value of statement to be equal or greater than 3. If not, set it to be less than 3. So here we get. So here we're printing this from an if statement, and it's going to behave exactly the same as the ternary. So now we're printing the result of doing it through an if statement, and the result of doing it through a ternary expression, like that. Should be the same. They should behave exactly the same. There we go. And if we change that to 1, it's now going to return. The first bit's now going to return false. So they should behave exactly the same. So you could just think of a ternary operator is like a very simple shortcut of doing an if statement like that. That's your condition there, and that's the if or the else there. So that's what a ternary operator is. So just a few things that tie into what we've already learnt in previous sessions. Both the possibilities, in other words, the 2 things that you could possibly be assigning the statement to, must be of the right type. Like, for example, here, we know statement is a string, so that's fine, because we're saying, well, assign it to that if this is true. Again, it'd be better if we use brackets there. It just makes it nicer to, easier to read, even though it's valid without it. That doesn't, because that's actually an int. So to make that work, you could do that, of course, and now it does compile. So they have to be of the right type. So you can use these ternary expressions with any data types, strings, primitives, whatever. But of course, if you're going to do that, you have to make sure they genuinely, so in this case it's a string, you have to make sure they genuinely are strings that you're assigning. When you tried it there with an int, it didn't work, because you're trying to assign an int to a string, so that doesn't work. Just to show here's an example of exactly the same thing, but we're actually using an int this time. We're saying set the value of ternary int to 1 if value is greater than 3, or 1,000,000 if it's not. So if we just print that out, because the value is actually equal to 3, so it should go in there. And it prints as 1,000,000 out here. And this is something just to mention as well, which I think possibly should have been covered in Chapter 1, but I don't think we went into it. As of I think it's Java 7, or it might be Java 8, you can use underscores in numerics just to make them easier to read, because I think it got to the situation where you might often have really, really long numbers, like that, like that. Obviously that doesn't compile because we're calling it a long, and we're now it compiles. So to make it easier to read, the Java now allows you to put underscores in there like that. And you can put them wherever you want. You could put them after every 0 if you wanted, but it makes sense to put them after every 3, like we do in conventional expressions, just to split numeric types up. I'll change that to a long, because we're using a longer number now, like that. So you can use underscores in words. So I'll just run that again now. Now we should get a much longer number there now. And of course, it doesn't come out in your output, so you don't see those underscores in the output. It's just to make it read easier. So when Java compiles it, it doesn't include those underscores. It's just to make it read easier. And just a few rules about those these underscores. You can't have them as the first, like as the first character of a number. So you can't do that. And you can't do them as the last character like that. And if you had here, for example, you've got a double, you can't do either sides of a decimal point like that either. You could do that, and you. Sorry, wrong one. So that, even though that looks bizarre, it does actually work. As long as you don't have them as the first and last characters of the number or either sides of a decimal point, you can use underscores. So that's just something to mention in passing, really. Yeah, so there we've done our ternary operator using strings there, and that statement there is exactly equivalent of this if construction there. The first operand, you're asking a question, yes or no. If the answer is yes, you use the first one. If the answer is no, you use the second one. So it's simple as that. And we used it. We used it with a long. It was int, but I changed it to a long because we're using a longer number there. Yeah, hi.
Use a ternary rather than the if statement. What benefit does it have? Does it have a benefit over the if statement?
Well, I suppose the only real benefit is saving lines of code, really. So you've got that's 5 lines of code, and that's 1. So that's
for
yeah.
To read in the if statement.
Yeah.
Java's strength, isn't it? Being meant to be able to
Readability.
It's easier the if statement to me.
Yeah, absolutely. So it's a personal choice, really. You could save a few lines of code by doing it that way, but then, as you say, if you're more used to if statements, it's more readable. Perhaps it's the if statement. Perhaps the ternary one is a bit more readable when you see it like that. Because when you've got strings in it, it does look a bit weird. But when that's maybe a neater way of doing it. But yeah, it's just a personal choice, really. And I think you're probably right. I think most people probably do just use if statements rather than ternary operators. But you just have to know that they're available if you want to. Yeah, I mean, this is just re-emphasising what we already covered about arithmetic promotion. In fact, we already covered it when we looked at this anyway. We tried to assign that to an int, but we can't because we've got a long there. So it's exactly the same principle here, because we've got an L there. So to make that compile, we could just get rid of that L there, because remember the L forces something to be a long, and that compile. Or if we really do want that as a long, that would have to be a long. That's just obviously just revision of what we've already done. Yeah, just to show this last example as well. In the earlier examples, we had our choices as just literals. So I'm saying use the number 1 there, or use this massive number here. But you can actually have expressions in there if you want to. So you're saying here, okay, the first part of it is y greater than 5. Yes, it is. It's going to take that. Otherwise, take that. But you can see it's actually doing. It's not just assigning a number. It's actually doing some maths in it there. So if we do that now, just print the answer there. It prints 20 there. But if we had is y greater than 12, like that, it should go to this one and print 30. So you can, because it multiplies that by 3. So you can do sort of manipulations in these things as well. Just to show again here that oh, wrong one. This is exactly the same thing here, but without brackets, and it looks really, it looks horrible really, because you've got all these things strung along. You don't know what's going on here. So it's just to emphasise that it's much better if you do use brackets. It just makes it read better, even though that would work just the same. So that's the ternary operator. It's an alternative to if, and I think Peter's largely right there. People tend to just stick with if because they look better. They look. It's obvious what's going on with an if statement there. So, and talking of if statement, let's go on to that, to discuss that now. I think you probably all pretty familiar with it already, but let's just go through what the book tells us about it. So we're going to here's an if statement. It looks quite similar to the one we just looked at in the ternary operator. The only difference is we've got an else if as well. So there's basically 3 things you can have in an if statement. You can the initial if, then else if, or else. And else if, you can have as many of those as you want. I think there's an example later on where we've got a few more. And these conditions, so that they have to evaluate to a Boolean. Because again, you're asking a question, so it'd be no good just putting like that. You're saying if 3, because if 3 just doesn't make any sense. It has to be something that return. It's like you're asking a question: is value greater than or equal to 3? It has to return a Boolean. Obviously, if it does, it'll go in there. This should be unreachable because you're saying here, is value equal or greater than 3? Well, if it is, it should never get in that one, because here you're saying is value greater than 4. Well, if it was greater than 4, it would already have gone in there. So that's kind of an unreachable statement. So Java doesn't check that you've got unreachable statements there. So if we made that, so if we run that now, let's print the value statement there, and if statement. So the value of value is actually 3, so it goes in there, and yes, I've got another. I'll just get rid of that because it's confusing the output. It comes into it in a minute. So it's gone to equal or greater than 3. So obviously, if we made it to 1, it will go into the less than 3. And because we've gone into this less than 3, because we've gone in here now. So if we just put breakpoint on there and debug it, because. Right, so it didn't do that one, so now it's checking this one. Didn't do that one either, so now it's gone into the else. It's gone into like the default. So it was setting the value to less than 3, but while it's there, it's going to do another print out. So it's going to just print that 3 there, which appears there, and then it's going to print our value out there. So fairly standard stuff really. But I've put a little note in there. So I'll just run that again now. I put a note in there. This is using brackets. Please do this for me because I much prefer it this way. Basically, the code block following the if, you can use brackets. It makes it readable to use brackets, but you don't have to use brackets if there's only one statement. So if you took that away, for example. Every single one of these possibilities only has one line of code in it, so you don't actually need those brackets. But what I say is that even if you don't need them, put them in anyway because it just reads better. Here's an example of exactly the same thing. So this is exactly the same thing as that, but it doesn't have those brackets, and to me it just doesn't look as good. It may maybe save a few characters of code, but it doesn't look as good. And I think it can also be quite misleading as well, because if we take this out, for example, if we make that 3, so you might think that they look the same, so you might think they're going to behave the same, but if we actually I'll comment that one out so we can see what in the first one what we get is we get equal to or greater than 3 and 3 being printed there. In the second one we don't get that 3 being printed. So can you see? So they've kind of done a similar thing, but that 3 hasn't been printed there, and the reason being is that it looks like all these follow that else there. All these follow that else, but actually they don't. If you do it without a bracket there, it's only the one after that gets followed. So these 3 are kind of masquerading. These 2 statements here are kind of masquerading as though they're part of that else, but they're actually not. And one way you could see it is if you did code. It is reformat code. There we go. It now puts those at a different indentation, so you can see that it's not actually part of that else. But really, that's just to illustrate that even though you don't have to use brackets, I would always use them anyway, even if you only have one statement in there, because it just looks better. It's more readable, but you don't have to. But it's better if you do. So just a few rules. So if statements, they obviously must have an if clause, otherwise they wouldn't be an if statement. So that's perfectly valid there. All these are compiling, you can see. But the other ones are optional. So you can have else ifs there, or you can have an else. So an if and an else if, or an if and an else. Or you can have all 3. We've seen that already. And you can have multiple else ifs. So any combination is okay, but obviously you can't have an else before an else if, because an else is like a catch-all thing at the end, and the else thing doesn't have a condition, because you're basically saying, okay, I've tested that thing, neither of them return true, so just do this now, just do whatever the result is, just do that. It's like a catch-all else thing is, and it can sometimes be dangerous if you don't have an else there. Because you can, and we'll see this when we do exception handling, because if you think your code's gone through one of these, but it actually hasn't, it's another way of causing things like null pointers and things, because you might these steps might all be initializing a variable, but none of these conditions were met. So your variable, if you don't have that, if we're here, your variable here, if you don't have the else, will be null at that point. And then later on you might try and use it and get a null pointer exception. So it's usually nearly always worth having a final else there, the catch-all thing. Another thing to say is that with these ifs, you can have nested ifs. So here we you know, you can see this is starting to look quite complicated now. So we've got the primary. If we get rid of that, so we've got obviously the primary statement similar to before, but you can actually, as part of the clause of one of the else's, put another level of ifs inside it, and you know, you could do it inside that as well if you wanted to. You could make these nested, but that's something to avoid. Once it starts looking really horrible to look at and difficult to follow, you should ideally avoid it. If you have multiple nested if statements like that, it's not very nice to read. It's quite good potential for bugs as well. So in that case, you'd probably be better off at looking at an alternative way of doing it. So, you know, splitting this out into smaller methods, for example, or using a switch statement instead. So that's the thing we go on to next, switch statements. And really, switch statements are used when ifs get a bit too, when really if and else ifs are kind of beyond what you want to do without it going overly complicated and nested and branched like this. So you can put multiple conditions in an if clause using the operators we've covered already. So this is like the or conditional operator, and that's the and conditional operator. So we've added a couple more variables in there. So we're saying if value is greater than or equal to 3, or another is equal to 6, which it actually isn't, is equal to 5, and 4 is greater than 3, then do the following. And unless you say otherwise, it'll just evaluate these left to right. But you can use bracketing to override that. So in this case, that's now a kind of a mini statement in its own right. So this is like this or all of that together. So you can do that. But again, I think where possible, should avoid doing too much of that. But it's very often the case that you'll see two things in there. And if you remember before, we actually if we do an example with an object, because of course I've been using primitives here, but if we have like an object, so at this stage we'll just make that null, and I think we covered this in the last session. If you've got an animal there, and if you want to start doing manipulations on that, like find its name or set its name or whatever, find its age, you would usually do like check, well, is it null first? In this case it is, because we're initializing it to null. So if it's not null, if it's not null and get name is not null, then you know so it's like you're setting up a guard. Then you know you're safe to do something with that. So you do system.out. No. So that's a good example of where you'd use like two expressions and a conditional operator in an if, because you want to do, you want to check what the animal's name is, or do whatever you want with that animal, but you can't do it if it's null. If you were to try and do that without the if statement, you get a null pointer exception. So if we run that, we should get a null pointer exception there. There it is, null pointer exception there, because we're trying to get the name off a null object, so it obviously doesn't have a name. But if we do that, we won't get a null pointer exception. So it just doesn't go in there at all. So that's another good example where you use conditionals in an if statement.
In the example you did above, those brackets down a bit.
Sorry, this.
In that or statement one.
Oh yeah, the one with the or statement. Yeah, here.
Do those brackets make any difference around that? Another.
Well, they do, because what you're saying is you're basically saying that at the level of the if statement, you've got two things. You've got that, and then all that. So as far as the if statement is concerned, you've got two things. But then, when you drill into this second one, that itself is made up of two things. But if you didn't have the brackets, the if statement would think, oh, it's got three things, so that, and that. So it would look at them as three separate things to be evaluated in turn.
So it does the another bit first, and then with the brackets around it.
That's right. So it would check that first, and then that in that order. And of course, with these well, they call them short circuit operators, these conditionals. If you're looking for true and the first one evaluates to true anyway, it won't even bother to do these because it knows that you're just looking for any one of these to be true. So it will do that first, and then in this case, so in that case, it would, if that equaled true, it wouldn't even bother going into there, but in this case, it would say, okay, if that's true, it won't bother doing this one, but then you've got another and here, so I'll check that one. So it looks a bit confusing, which is always why it's better actually if you do use bracketing where possible. But yeah, so with that one, none of that at all will get evaluated if that one equals true. But if in that case, that one still will. So it's a bit of a complicated example, and maybe I'll do some docs, Java docs in this class, and some actual worked examples to show that working. But yeah, these things can get quite complicated if you don't use bracketing, or if you have too many of them strung along. Yeah, so it's always worth to just making them as clear as possible and avoiding them too many levels of that. Avoiding too many levels of that. So as we said, when the if statement starts to get too complicated like that, when it basically doesn't read very well, you might want to consider a switch statement, which is the next thing to cover today. And what I would say is that switch statements are much less used in general than if statements. If statements you see all over the place. So I'd say like in like business logic, the kind of code we use here, for every like 100 if statements, you might see one switch statement. They're not that very well used, but they have their place and they're quite handy in the right circumstances. And so we've got these variables size and cost here. And one thing I was because I was trying to reiterate things we've already covered in previous sessions. So these int and cost, before we even look at the switch statement, you can see that those are method. Remember, we've got three levels of variable scope. We've got method locals, static class variables, or instance variables. So these are method local variables because they're defined within a method. But you could now, if I take them away, obviously this doesn't compile anymore because it's saying, oh, what's size and cost? Right, there aren't any variables called that because I've just deleted them. So would anyone know if I just pasted them now at the top of the class, what would happen? Would that compile or not? If I pasted them in there, it would compile. Well, you sure about? Well, they don't, right? But there's a very specific reason why. So they're visible from there. But this is a static method. Remember. So this method belongs to the class because it's a static method. But they're not static variables. They're instance variables. So one way you could either fix it by doing that. So that now compiles. But then we don't have our public static void main method. So we couldn't run this switch statement. Like if I try and run that now, it should complain. I know this isn't what we're covering today, but it's just a bit of revision. It's saying no, you haven't got a main method. It's saying you need a public static void main, because if you remember, you need a static method to be able to start a class, because if you don't have a static method, you must have an instance of the class. And you can't, and it's like the chicken and egg thing, you can't start a program with an instance because you need to run something to create an instance. So the only way you can create an instance without having one first of all is by having a static method, because that's owned by the level of the class. So it's what we dealt with in chapter 1 anyway. It's worth revisiting quite regularly because it's quite complicated. But the point is that these variables are class variables, so they only exist in the context of an instance. So if you created a new instance of switch statement, then you could access them through that. So you could do this. Equals new. So now what we're doing, we're saying, right, give me a new instance of switch statement, an object on the heap, an actual concrete object on the heap. At the moment, when we're running this main method, it's just in the abstract. It's just a class that's been loaded, no instances of it. So now you could access that. You could access it like that through the instance like that. But a quicker way of doing it is you could mark those as static. So that means they themselves are now owned at the class level. They don't need an instance to be accessed or to exist. So that's just like reiterating the whole static instance local thing and the variable, the access limits of both. But the idea of static, it gets covered in chapter 1, as we already have covered it, but it gets covered in a lot more detail in later chapters. So it'll just keep sort of referencing it occasionally as we go through, and then we'll do it in much more detail later on. But hopefully you can see why that doesn't compile if those aren't static. It's because they would rely on there being an instance of that class to be usable. Anyway, that's not what we're meant to be covering. It was just revisiting that thing from what we did in chapter 1, like the 3 different levels of variable scope. So anyway, there's a basic switch statement like that. And it's basically this sort of a structure. You switch on a particular variable or literal. So here you're saying this size variable. We're gonna check what that is, and depending on what the answer is, there's various things we can go through. So you can see this is a bit like an if statement, but it's potentially a bit more powerful, and it's sort of laid out the way you can have lots more choices and things. You could make that doesn't have to be a variable in there. It could be just a literal if you wanted, so switch on 1,000. But there's kind of no point doing that, because you're testing what's the value of this. If you know already that it's 1,000 because you've typed it in there yourself, then you probably don't need the switch statement. But just to say that it does compile. So to go back to this again, so it's actually set to 10 at the moment. So if I just put a breakpoint on that and just see what happens if we run it, I'll just comment out any system outs there. Catch later on. So this is switch statement. So I'll just run that. So there we go. So it's going to check. It's going to look at the size, and we know that size is 10. If you hover over it in IntelliJ, it'll tell you. So it won't go in there, and it won't go in there. But a bit like the else of an if statement, there's the idea of a default in switch statements. So if all else fails, do this kind of thing. So if we let the thread move on, you see it's gone down straight to there because none of those were true. So what it will do, cost is 10, so it will increment cost. I'll just uncomment that and do it again. So we're expecting that will print out 11 basically, because it starts at 10, gets incremented, it'll print out 11. So I'll do it now without the breakpoint in there. There it is, prints out 11 there. So one thing to so if we set it to 30, so what will happen this time is that it should get caught by this clause here. So there we go, it's 30, so it has got caught by this. So cost, which is 10, will get incremented once, then again. So cost now, if we hover over cost, should be 12. Yeah, 12. And then we reach this break thing, which completely breaks you out of the switch statement. So it goes to our printout, and that should just give us the 12 there, which is fine. So I stop that. But one thing to mention is that if you don't put a break in there, it will go through and do the next one anyway until it reaches a break. So what will happen in this case, it'll go into let's see, let's actually do it. It'll go into the 30 because it does equal 30 and do those two. Now last time that hit this break, so it left that statement and went straight to here, but this time because we don't have a break, it goes into the next one too, and it would do that. And if you imagine there were 20 of these case statements, it would go through every one of them in turn until it reached a break, and then finally it will go here. So this time that should equal 13, because there it is, because we didn't have that break in. So it's normally you do want those breaks in there, because normally you just want that particular block of code in your case statement to work out. Occasionally you might want just your bit of code in your case statement plus the default one, perhaps. But usually you just want to break out of that point there. So we've got a few other things to say about switch statements here. Obviously that's it in its simplest form there. So the things that so the cases that you've got here, now they actually have to be constants. Now here they're constants because you've specified them as literals, as you've actually, in other words, you've actually written yourself what they are. So if I was to put cost in there, that doesn't compile. I wonder if it'll just tell me why if I just hover over it. Okay, it's still in a breakpoint. So if I've stopped the thread of execution now, it might tell me what the exception is. Yeah, it's saying, oh, hang on, you can't use cost there because it's not a constant, because cost is just this static int cost. So that might seem a bit weird. What does it mean by that and why? Because that's absolutely fine like that, because you've written the number, you've typed the number 40 in there. It is a constant. It's not going to change, so it's fine by that. But if we put cost in there, I'll put another one in there because cost we're using later on. So let's just int test int. There we go. 5. So if instead of that 40, well, in fact, let's, as well as the 40, let's just add another case in there. So test int like that. Also, you notice when I copied 2, it knows that they're the same. It knows that they're a duplicate. So it doesn't allow that. It can tell if they're the same or not. If we made that 41, it wouldn't complain. But let's try putting an int there instead of a constant. And now it complains. It's saying no, that's constant expression is required here. So the reason it needs a constant expression is that it actually evaluates what these case values are whilst it's compiling. So in other words, this all gets compiled into byte code, and it needs to be able to know at the time when it's compiling it what the value of this expression is actually at that time, because here it knows it's 40, so it hardwires that 40 into the byte code. Here it doesn't know what the value of that is. Now you could say, oh yeah, but you could look there and see that it's 5, but it's not that clever, because that's a test int. You could have been doing things with that. You could have been doing test int plus plus, and it doesn't know. It's not kind of clever enough to say, oh well, let's just look at every line of code that he's used that test int in just to be sure what the value is. It's not that clever enough to do that. So what you have to do, you have to make it a constant. And do you know anyone know how to make that a constant? Anyone? Well, obviously you could hard code it like we've done there, but another one, and it's another keyword that we use a lot later on in the course, is final. So when you do final, that means that you can't change it again afterwards. So that test int is 5, it's always going to be 5, and that's proved by this thing here. Suddenly this doesn't compile anymore. The reason it doesn't compile is because it's saying, oh hang on, you've said that this is final, and now you're trying to increment it. This now compiles here, but this doesn't. Now it's the other way around. This does, but this doesn't. So you have to make that a final, and you can't mess around with it afterwards, because the very definition of something being final is that you can't mess around with it. Once it's set, it's set. And in normal Java, I mean, outside of a switch statement, with final variables, you do actually have the option of actually initializing a final variable and then assigning it on another line like that. So that's perfectly acceptable Java. Even though it's a final int, you can set the value just once. If you tried to do it again, it would tell you off about it. So if you try to do that again now, it's saying no, you've already set it once, you can't do it again. But just in the case of switch statements, it doesn't even allow you to do that. So if I try to use that here, it doesn't like it. It looks up here, it sees that you've done this, and it thinks, oh no, he hasn't given it a value. It kind of gets confused. It's an absolute requirement in switch statements that is a final and set on the same line. It's just not clever enough to work out that you've done that. So it's just a bit of a quirk of switch statements, really. But otherwise, they're fairly intuitive. And here we've got another one here where we've got large and medium, and again we've set them as final ints, and we're doing cases based on them here. We're doing cases based on large and medium. So again, if those weren't final like that, that doesn't compile. So I think that second example was basically was there to illustrate the use of final there, but we've already covered it in the first one, so I think we can pretty much run through that again, because it's basically a very similar example. Final, and then now that compiles fine. There we go, very similar example. So in the case statements, we can use literal. Obviously we can use literals like this because they're effectively constants, or we can use final variables like that. Another thing we can use is enums. Now I don't know if you know what enums are, but they're not covered to much degree in the exam. But basically, what enums are is they're like a restricted set of values. So, for example, here's one that's used in this is an actual class from the main Java distribution. So Java time package, which we see a lot of in Chapter 3, and it's called Day of the Week, and it's an enum. It's of type enum. And basically, it's basically restricting the values you can use based on pure logic, because we know there's only 7 days of the week: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And so it's a way of capturing that. Like, for example, you could tie what somebody can enter into a drop-down box based on an enum, and that would stop them just typing in a made-up word where it can only be one of these 7. So an enum is like a very discrete, definite set of values, and day of the week is one of them. So you can use a switch statement with enums like that. So I think we've done it actually. I think we've done. In fact, the first time we did this course, we actually set it as some homework, which Richard did very well. Actually, Richard did it very well, and. So here's an enum based on the day of the week. So if we just run through this one, actually there are two of them here, conditionals, and one fixes a bug that's in the other one. So I'll just make sure I got the one with the bug first. Yeah. So first thing to say is that so if let's use that enum. So day of the week is that enum that I was just showing you before. It's the day of the week written by the main Java team. So we're saying, give me the day of the week for Monday, and give me the day of the week for Sunday, and let's just print those out. So switch statement with enum. There it is. And it just prints out Monday and Sunday. No surprises there. But what it actually does, if you look a bit deeper into this, it gives them a code. So basically, these are indexed enum. So Monday is 1, Tuesday is 2, Wednesday is 3, etc. So if you just bear that in mind, what we're going to use in a minute, we're going to use the calendar object to work out what day it is today. But before we do that, let's just print out a few things here. Right, so Sunday from a calendar object has a value of 1, whereas in the day of the week enum it has a value of 7, like that. So it just means that the day of the week enum starts with Monday and ends in Sunday, whereas the Java calendar object it kind of does it the other way around. Sunday for it is the first day of the week, and then Monday, Tuesday, etc. So if we just, now Sunday is a particularly sort of difficult example, but if we use Monday, so here we're getting that. So here we're getting the value, we're getting the Monday out of the enum. Then we're saying, well, what value is it? What is your index value of it? And similarly, we're doing the same for a calendar object. Don't worry too much about calendar object. We'll deal with that in a minute. So from a calendar object's point of view, Monday is 2. But from the day of the week's point of view, Monday is 1. We know that. We know that because it says there, Monday is 1 in the calendar in the day of the week enum. But from a calendar object, which is what you use to get today's date, Monday is considered 2. So what that's leading up to say is that if you adjust the one in the calendar by -1, then they become comparable. So they're both 1 now, so they're directly comparable. So just stay with me and you'll see where this is going in a minute. That in Java is how you get right this very moment to nanosecond precision. You say calendar.getInstance. It gives you a timestamp of right this minute. And we can, from that calendar, we can get the current day of the week. We can do it like, in fact, let's just split this out a bit. We can say int day of week as int equals cal, which is this timestamp we've got right now. I'll just copy it from there actually. Get the day of the week. So you can get any element you want out of this object. You can get the timestamp, the day of the week, the month, the year, anything you want to, but we're getting the day of the week as an int because the calendar stores it as an int. But as we know, it's kind of 1 out from the enum day of the week. So we take 1 away from it. So now we look up the day of the week from this enum based on this calendar object -1 from it. I know it all seems a bit complicated, and then we can do a switch on that day of the week. So if we what I'd say is it probably seems a bit overly complicated and weird just going over it for the first time, but if you have a look over this class and read through it yourself, it should start to make sense what we're doing here. So if we run that and it should just print out what it's Thursday today, so it's midweek, so what? So yeah, it's midweek, so what? So it's printed out the one for Thursday. So what we've done, we've got the day of the week out of our timestamp, and we've looked up in that enum what does that day correspond to, and then we've based our switch statement on that enum. So it's a contrived example. It's a contrived example that shows both how a switch statement can use enums, and also how an enum can itself be looked up to get things out of it. So it's a bit of a contrived example, but if you look through that, it works. But then when we sat this as homework in May last year, Richard spotted something. I was very impressed he spotted it. This will work for every day of the week except Sunday, because Sunday it won't work, because we know here that we know from this first bit that whereas like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, they're just one out from each other. In the case of Sunday, they're 6 out from each other, like that, because the day of the week considers Sunday as the last day of the week, and the calendar considers it as the first day of the week. So what Richard did last time round is he actually implemented a ternary operator, which the first thing we dealt with today, to say, well, actually, is this day of the week a Sunday? So we're getting from the calendar object, we're saying what is it as far as the calendar object's concerned. If it was Sunday, that would be 1. Then you take 1 away from it, it becomes 0. So you're saying, well, has the calendar object returned 0 to us? In which case it's a Sunday. If it has, then set it to 7. So we don't want it to be 1 anymore, we want it to be 7, so that it will look up in this enum, okay? Otherwise, just use what it was before, because all the other days of the week, it's fine as long as you've applied that adjustment of 1. That will work. So basically, this example here shows you how to use an enum in a switch statement, and it kind of does this little bit of a kind of a bug fix to work to account for Sunday, and of course you could have used a standard if statement there if you'd wanted to. So having said all that about enums, I don't think they're actually on the exam. But I just mention them in passing because it's nice to know that they exist, and they make logical sense to have collections of effectively strings, indexed strings, to limit choices where because there are only 7 days in a week, so it makes perfect sense to just have those 7 options.
John,
could you
have your own day of the week class and just reorder them?
Yeah, so you could write your own enum.
Just to line it up.
Yeah, exactly. Exactly. So you could effectively copy and paste that entire class, but just put it in your own package, and reorder them here, and then it would line up with that calendar object. But all of that is, even talking about calendar objects as well and enums, it's more than we need to know for the exam. But and don't worry if not all that seemed obvious, if it's a bit confusing. If you read through it a couple of times, it probably will become a bit more clear. But it's just to show, like one of the uses of switch statements really, and how you can use enums in them. But enums aren't on the exam, and when we do, we do a lot about date and time. You can see there's a whole package waiting for us where we do a lot about date and time, and here we meet the calendar object again. So we'll learn a lot more about that calendar object in further sessions. But one thing you can say straight away about that calendar object is, if you're sort of getting an eye for this now, you can tell just by looking at that get instance method is a static method, because it can be called directly from the class name. If it wasn't, what you'd have to do cal equals new calendar, and I don't think it even allows you to do that. No, okay, I didn't want it to do that. It's tried to override it for me. So and then you'd do cal dot get instance on the instance. But the thing, it doesn't force you to create a new object. And if you try to create a new object, it doesn't even let you do it. As we'll see in later chapters, sometimes you shouldn't create a new instance of a class. Sometimes you should only use its static methods, and there are ways to protect against doing that. See, this constructor in the calendar class is actually protected here, which means that you can't use that constructor unless you're within the same package as it. But anyway, we're getting ahead of ourselves here. Just introducing this is a commonly used class in Java's calendar class, and if you do calendar get instance, it returns you a date timestamp of right now, and we'll deal with that later on when we look at dates and times and things. So that's basically finished off chapter 3, pending 1 or 2 little extras to do. So we'll finish it there for now.